Welcome back to this episode, taking a further look at probability, and in particular we're going to look at independent and dependent events. So an independent event, or two events that are independent if they don't affect each other. So if we've got an example would be if we have the toss of a coin. If we do that twice, the first event is completely independent of the second event, because the results do not affect each other. But two events are dependent if they do affect each other. For example, if it's raining, the probability of that happening, and the probability of me taking an umbrella to work or to school. Those are two things that are dependent events. But two things that are independent would be if it's raining and me eating a ham sandwich for lunch. Those two things aren't linked in any way. Now, picking balls from a bag with replacement results in each bag, in each pick, being independent from each other. So if you've got a bag of balls, what that means is if you take a ball out of it and put it back in, each event is independent. And the reason for that is because the first event doesn't change the probabilities of the second event. Now, if you don't put the balls back in, now that suddenly does affect the probabilities. The reason being that if you take a ball out, you look at the colour and you put it to one side, and you don't put it back in, then less balls in the bag, and that's going to affect the probability of you choosing your next ball. So if you do replace the balls in a bag, that is independent, because those picking a ball again will not change the probability. But if you leave the ball out and then pick another ball, those are dependent events. So remember, two dependent events will affect each other. And something to say about independent events: if you're picking a ball from a bag and replacing it and picking a second ball from the bag, that's one example of independent events. Another one would be having cornflakes for breakfast and taking an umbrella to work. Another one would be tossing a coin and picking a card from a deck. Now, you also need to know how to calculate certain probabilities. So for any two events, if you want to work out the probability, let's call those events A and B, okay? So probability of event A and probability of event B. If want to know the probability of event A or B happening, so either, you don't mind which, you just want to know the probability of one of them happening, then what you can do is you can take the probability of A, add it to the probability of B, and then take away the probability of both A and B happening. So I'll say that again: the probability of A or B happening is equal to the probability of A plus the probability of B, take away the probability of both A and B. Now, if you want to look particularly at independent events, you can say if you want the probability of A and B happening, so you want A to happen and B to happen, then you can do the probability of A times by the probability of B. And mutually exclusive events can't both happen at the same time. Now remember, for mutually exclusive events, the probability of A and B happening is equal to 0. So what you can say is the probability of A or B happening, you can just add the probability of A plus the probability of B. But that's only for mutually exclusive events, because they cannot both happen at the same time. So if we've got the probability of Maria getting a question right in her Spanish test as 3/4, 3/4, what is the probability of her getting the first two questions correct? Well, if she got the first question right, the probability of that would be 3/4, and the probability of getting the second question right is completely independent of whether she got the first question right. So the probability is also 3/4, and what we do is we times those two together, because we're trying to work out the probability of both those things happening and their independent events. So 3/4 times 3/4 will give us 9/16. Another question. So the probability of Stella getting a question right in her Spanish test is 1/5. What is the probability of her getting the first two questions correct? Well, if you've got 1/5 chance of getting the first one right and 1/5 chance of getting the second one right, those two events are independent. They don't depend on each other in any way. U times 1/5 times 1/5, probability of A times probability of B, to give you the probability of both those things happening, which will give you 1/25. Now, there are 3 balls in a bag. 1 is red and 2 are blue. What is the probability of drawing a blue ball and then a red ball, and the first ball is replaced after it has been drawn? Now, the important thing to realise here, first ball has been replaced after it's been drawn. So those are independent events. So you can work out the probability of getting a blue ball in the first one is 2 out of 3. The probability of getting a red ball in the second one is 1 out of 3. So times those two together, 2/3 times by 1/3 will give you 2/9 in total. And really, really important, remember that definition of mutually exclusive events. So mutually exclusive events can't both happen at the same time. And some examples of dependent events, we looked at independent events earlier, but let's look at dependent events. So that might be something like the train being cancelled and me being late for work, being sunny and the number of people wearing sunglasses, and also picking a ball from a bag and then not replacing it and picking a second ball from the same bag. Those are all examples of events that are dependent on each other. And that is all we're going to cover today in dependent and independent events. This is also closely linked to tree diagrams, which we're not going to cover in this episode, but I recommend you go and do some revision on that because it's very closely linked to what we've talked about today. Thank you for joining us and see you again soon.